People cause accidents. To be more exact, people not paying attention or doing something that they shouldn't be doing causes accidents. To put it another way, accidents result from varying degrees of carelessness, sloppiness, negligence, inattention, neglect, and ignorance. Accidents also happen where two things are found: unsafe acts and unsafe conditions. Unsafe conditions occur when there is a failure to identify, control, remediate, or train properly against a hazard. Even though there can be multiple human causes, accident investigations will always identify the human failure to correct the hazard. Some unsafe conditions are easy to spot. Finding others needs a closer inspection. For example, liquid on a walking surface is an unsafe condition, but you won't see it if you aren't looking where you are stepping. People create the majority of unsafe conditions. Mother Nature can create conditions, but she gives us plenty of warning signs. If it's cold and wet, or raining or snowing, we should be aware of walking hazards. No matter what nature is up to, we can be aware of it and guard against it. However, unsafe conditions created by people are often harder to find. Overloaded circuits, unguarded machinery, unchained cylinders, altered safeties, blocked fire extinguishers, blocked exits, curled up edges of mats or carpets, spills, poor lighting, unsanitary conditions, speeding, damaged tools, and inappropriately stored chemicals like solvents and gasoline, and poor housekeeping are all examples of unsafe conditions created by people. If you see an unsafe condition and ignore it, you just made it more likely that someone will fall victim, perhaps even yourself. Unsafe acts create unsafe conditions. Unsafe acts are things like failing to properly do a job, failing to see hazards, or taking unneeded risks. For example, speeding up to make the yellow light, using tools in wrong ways or using damaged or defective tools, not using proper personal protective equipment, ignoring the safety data sheet for chemicals you are using, or deliberately violating safety rules and procedures. How many unsafe acts can you spot today? Which ones are you doing? The worst kind of unsafe act is deliberately creating an unsafe condition. Have you done anything to make the job more risky for you or for others? Although it is difficult to foresee every condition or potential hazard, it's hard to find an accident that could not have been prevented. The person injured may not have caused the conditions that caused the injury, but something they did or something another person did directly led to the incident. The facts from accident investigations are revealing. 99.5% of accidents are caused by people's behaviors. Some don't do it deliberately. Some don't do it because they just did something stupid. Others cause accidents because they think they can do it without getting hurt, or they don't think about the consequences of their actions. Some are in a hurry. They allow themselves to become distracted and are not paying attention. One thing to remember: you can make the same mistake many times without anything bad happening. I always did it this way, and nothing ever happened until today. Over time, you come to believe that some unsafe conditions or acts are okay because you have no evidence to the contrary. Whatever we do, our job is to identify as many errors as we can and correct them through education, process changes, equipment modifications, or any other way needed to ensure that we all go home safe at the end of each day. Thanks for watching, and have a safe day. One of our back safety videos is called the high fives. This one we call the low fives because this video covers 5 important ways to protect your lower back. The lower back is a vulnerable area that requires special attention to spare you painful injuries that can affect your lifestyle for the rest of your life. Follow the low fives every time you pick something up and put it down. Number 1. To pick up an object that is on the floor or lower than the level of your waist, keep your back straight and bend at your knees and hips. Do not bend forward at the waist with your knees straight. This puts too much pressure on the hinge in your lower back. Instead, use a position called the shortstop. This is the same stance that a baseball shortstop takes. Your weight should be balanced on both feet, and they should be at least shoulder width apart. As you bend down to get a grip on the load, use your leg muscles as much as possible. Slightly bend forward at the waist, but keep your back straight. Number 2, never twist while under load. Your body is not designed to do this, and it often results in injury. Your back muscles meet at your lower spine. When you lift and twist, it puts tremendous pressure on discs in the small part of your lower back. Do this once too often, even with a light weight, and you're asking for trouble in the form of a painful, possibly lifelong injury. Turn your feet. Do not twist at the waist. Twisting with a load in your arms takes your spine out of alignment, and that hurts. Number 3, before lifting, carefully assess the load. How heavy is it? Does it exceed your personal limitations? Is it too bulky to lift and carry carefully? How far is the load from your body? Can you get close enough to avoid straining? What kind of forces will you have to put on your entire body to get the load up in your arms? Will it involve pulling or twisting? How often are you going to be lifting loads like this? Is your body ready, muscles and tendons loose and warmed up? Don't skip on an assessment that takes little more than a few seconds. Number 4, posture. Always keep your back as straight as you can. Slouching or curling your spine weakens the spine and all its support structures. When you are sitting down, tighten your stomach muscles to keep you from slouching. Center your head between your shoulders and don't let it hang forward. Practice keeping your chin up. This will help you center your head. The average adult head weighs about 10 pounds. To get an idea, go pick up a 10-pound bag of sugar or a 10-pound bowling ball. That's a lot of weight on your spine, and poor posture puts a lot of pressure all the way down to the base of your spine. Keep good posture all the time, at work, at home, anywhere. It will keep your back stronger. Number 5, most back problems develop over time, and when the big injury comes, it's usually the result of many, many small injuries. Over the years, we tend to exceed the capabilities of our muscles, tendons, ligaments, and most important, those vital discs that make up our spine. Lower back injuries can be avoided, but they require you to follow safe lifting rules all the time, not just once in a while. It doesn't matter where you are lifting or moving something, a box at work, a piece of furniture at home, putting a bag of groceries into your car. All can cause tiny tears and traumas to your spine if done incorrectly. Follow safe lifting rules for your whole life, and you will have a healthy back for a lifetime. Before you lift anything, take a moment to consider these 5 important guidelines. 1. How heavy or bulky is the item being moved? Know the weight of the load before you try moving it. Also, is the load too bulky to handle by yourself? Are there any other special considerations before lifting? Can you clearly identify the points where you can get the best and safest grip on the load? 2. Can you lift the load manually, or will you need help? Help could be in the form of a second lifter or a step up to some type of a mechanical lift assistive device. You should know your personal limitations. In other words, what amount of weight can you safely lift without risking injury? Even if the load is within your limits, consider using mechanical help whenever possible. But if the item is heavy or ungainly, get help. Don't let your ego get you in trouble. Get a second person, a hand truck, forklift, dolly, or whatever else is available. 3. What location is the load coming from? Are you moving something from a hard-to-reach place like overhead or far back on a shelf? Does it have to be lifted out of a container? Is it in a tight area that may give you trouble? You want to be able to position yourself as close to the load as possible before lifting. The closer you are, the less strain on your body. If it's back on a shelf, slide it out to get it closer. If it is coming out of a tight area, make sure you have adequate room for your hands and arms. Watch out for pinch points. Be aware of any adjacent obstructions, and always make sure you can see the top before moving. 4. What is the destination point? Before you lift anything, think about where the load will be placed. Will it be going somewhere overhead, in a narrow, tight spot? What special precautions should be taken before you get to the end point? Will you have enough room? At the destination, don't try to shoehorn something into position. Allow yourself as much room as possible to set the load down. Avoid hitting anything nearby. You can always shift it after it's down. 5. What route do you have to follow while carrying or moving the load? Check the path from start to finish. Are there any tripping hazards, trash, or debris on the floor? Any holes that could break your ankle? Any changes in floor elevation that could throw you off balance? Any loose, uneven, or unstable footing, like grass, dirt, broken concrete, gravel? Will you be going through any doorways, blind intersections, or anywhere else that you should be aware of? Are there any wet, slippery areas? Very important, how is the lighting along the route? And if you are moving from inside to outside or from outside to inside, are you prepared to deal with the lighting changes? Traveling in or out of doors can cause temporary vision loss while your eyes adjust to the lighting changes. Remember, the shortest way isn't always the best or the safest. Know the high fives of back safety and always plan your lift. Worker was using a wire wheel on a sheet of metal when a tiny piece of wire shot out at high speed and pierced his eyeball. Not even 1/8 of an inch long, the projectile caused too much damage to save his eye. Think this is just a harmless little screw? It was in the grass when a man edging the lawn with a powered string trimmer hit it, instantly turning it into a missile traveling fast enough to shoot directly into the center of his eyeball, penetrating the pupil and embedding itself deeply in the vitreous body. A man using a handheld sprayer squirted parts cleaner on some metal pieces. The stream of spray bounced back and hit him in both eyes. When the solvent made contact with his eyeballs, it started burning through the tissues covering the cornea. Blinded and screaming in pain, the chemicals caused extensive damage because it took him almost 20 minutes to find his phone so he could call for help. The delay cost him most of the vision in one eye and 15% in the other. A maintenance worker was refueling a generator when some of the fuel spilled over and hit the hot engine manifold, causing a flash fire. The fire was strong enough to burn off most of his eyebrows and some of his hair. The skin around his facial area received first-degree burns. When he took his safety glasses off, the only part of his face that had not been touched was around the eyes. Doctors told him that the safety eyewear he had been wearing saved his eyes, and without them, he might have been blinded for life. Almost 70% of eye injuries result from flying or falling objects or sparks striking the eye. Of the objects that caused the worst eye injuries, more than 60% of them were smaller than a pinhead. Most of these damaging little missiles were traveling at high speed when they injured the eyes. Chemicals in the eye account for almost 20% of eye injuries. Good safety eyewear is inexpensive, lightweight, easy to keep clean, and scratch resistant. Choose safety glasses that meet universal standards for proper eye protection. For example, OSHA requires protective eyewear in the United States to meet the minimum standards established by the American National Standards Institute, or ANSI. If you already wear glasses, your prescription lenses can be made to ANSI standards. Most safety eyewear also blocks damaging UV rays, and you can get safety eyewear for indoors or outdoors, and you can even get ones that are bifocal with varying degrees of magnification. Remember to wear your eyewear when working around the house. More than twice as many eye injuries occur at home than in the workplace. But whether you're at work or at home, don't be blindsided in an accident. Wear protective eyewear.
Our topic today is hearing conservation. This material has been developed through a partnership that we have here at Morrow with the Consultation, Education, and Training Division of MyOSHA. and we're very grateful for that partnership. There is a standard, a regulation that's enforced by MIOSHA on this topic, and we'll make references to the standard throughout the course of the program. Our objectives today will include a discussion of noise exposure, a definition of the noise levels at which employers are obligated to respond and protect their employees, a little bit about the process of hearing loss, and some of the details associated with the MIOSHA standard on hearing conservation, audiometric testing, and a couple of different types of equipment that are used to protect employees and to protect their hearing. Your employer is responsible for determining the level of noise in the workplace and identifying employees who are exposed to noise levels at or above 85 decibels averaged over a typical workday. This is called an 8-hour time-weighted average, or TWA. Noise is defined as unwanted, excessive, or dangerous sound. If an employee is exposed to sound levels above 85 decibels over a sustained amount of time, then hearing loss can occur. It occurs in the inner ear. A short exposure to excessive noise may cause temporary hearing loss, but if the exposure stops, hearing can return to normal. This is usually referred to as bounce back. However, if you are continually exposed to excessive noise, parts of the ear can be damaged permanently, resulting in permanent hearing loss. Some of the warning signs of hearing loss include difficulty in hearing consonants such as S, the S sound, or T, the T sound, in normal conversation. There can be difficulty separating speech from background noise, complaints from others that you are talking too loudly, having to turn up the volume on the TV or the radio, difficulty hearing ringing telephones or whistles, or difficulty hearing soft sounds such as a child's voice or rippling water, or constant ringing in the ears. As it relates to the workplace, there are two types of noise: continuous or ongoing noise resulting from the use of equipment such as grinders, lathes, or other power equipment. And the second type of noise is impulse noise, or periodic noise, that would result from the use of pneumatic or impact tools or explosives. Both types of noise can be harmful depending on how loud it is and how long you are exposed. With regard to noise exposure, there are three factors to keep in mind. One is the loudness of the sound. Two is the duration or length of the exposure. And three is the distance from the source of the noise. When an employee is exposed to high noise levels, serious permanent damage can result. Although you may believe you are getting used to high noise levels, this usually means you are enduring hearing loss. As a rule, if the noise level is loud enough that you have to get used to it, hearing protection is probably necessary. Another rule of thumb for noise is that if you must raise your voice to be heard in the workplace, noise levels should be evaluated to ensure excessive exposures are controlled. Some examples of different types of noise levels, and loudness is measured in decibels, or dBA. Some typical decibel levels are a whisper at 20. Normal conversation generally occurs at about 65 decibels. A kitchen blender is as loud as 85 decibels. A lawnmower, 95. A rock concert, 105 decibels. And at the high end, a jet taking off, 145 decibels. The MIOSHA standard, titled Part 380, Occupational Noise Exposure, defines an action level as an 8-hour, time-weighted average noise exposure of 85 decibels. It's at this point that an employer becomes obligated to develop a hearing conservation program, conduct noise monitoring, do audiometric testing of its employees, issue personal protective equipment to make sure that the excessive sound levels do not harm an employee's hearing, conduct training on this topic, and to keep certain records. Audiometric testing monitors the sharpness of your hearing. If an employee is exposed to that action level at work, a baseline or an original test is conducted to determine hearing capabilities, and then an annual recheck is done to gauge whether or not hearing loss has occurred. This tests the ability to hear various decibel levels, and as I mentioned, is given annually to employees who are exposed to 85 decibels or higher over an 8-hour time-weighted average. There are two major types of hearing protection devices that you can wear to reduce noise exposure to below 85 decibels. One is ear plugs and one is ear muffs. Ear plugs fit into your ear canal, blocking excessive noise from reaching the inner ear and causing damage. When using foam insert ear plugs, with clean hands, roll the plug into a small crease-free cylinder between the thumb and forefinger. Next, with the other hand, pull the ear outward and upward to allow the ear canal to open. And third, insert the plug well into the ear with fingertip and hold in place to allow the plug time to fully expand. A few things to remember about ear plugs. They should be checked and adjusted throughout the workday. In order to be effective, they must fit tightly in the ear canal. Hands should be clean prior to inserting earplugs. Reusable earplugs should be cleaned with soap and water and then stored in their case. And earplugs should be replaced whenever they show signs of wear. The other type of hearing protection, ear muffs, are worn over the ear, preventing excessive noise from entering the ear canal. To use ear muffs, first inspect the inner linings for cracks, tears, or other signs of wear that will compromise the equipment's ability to protect employees. Center the ear muffs so that equal pressure is distributed around the ears for a tight seal. Push aside hair and earrings to keep from interfering with the seal created by the ear muff, and make sure that glasses or other eye protection doesn't interfere with that seal. A couple of things to remember about ear muffs. The seal should be checked and adjusted throughout the workday. When finished, the cushions should be cleaned with a wet cloth, and ear muffs should also be replaced whenever they show signs of wear. Employers in Michigan have an overarching safety responsibility defined by MIOSHA under the General Duty Clause, which is to maintain a workplace that's free from any recognized hazards. If there is something going on in the workplace that can harm an employee, the employer has the obligation to respond. As it relates to noise in the workplace, the employer can respond in three ways, as they can to any hazard. The first objective would be to eliminate it. So in this particular case, if there is a piece of equipment that's excessively loud, as an employer, if I could identify a substitute machine that could accomplish the same goal but ran quieter without as high a noise level, I have eliminated the hazard. If I can bring that decibel level down below the action level, well below the action level, then I've eliminated the hazard of excessive noise to the employee. If that machine can't be replaced, I could also have the option of containing the hazard. In this particular case with noise, that could be accomplished through containing it with a wall, a curtain, some type of a baffle or other device, other instrument, other material that kept the noise. It didn't eliminate the hazard, but it kept the noise from reaching the ears of the employee where it might cause damage. But the third and final option and layer of protection, really the last line of defense, is hearing protection, personal protective equipment designed for employees either through earplugs or ear muffs. Hearing conservation is a very important part of workplace safety, as prolonged exposure to excessive noise can cause serious and permanent hearing damage. I hope this information has been useful. If you have questions, feel free to contact me through the information that now appears on your screen, or if you would like more information on the regulation direct from MIOSHA, their contact information and website is also appearing on the screen. Thanks very much, and be careful out there.
Chances are you will go through your entire working career and never have to use a fire extinguisher. Chances are you will never have to use one while on the road, but there should be one in your vehicle. Have you inspected it lately? Close your eyes for a second. Can you point to the nearest fire extinguisher? Where is the second nearest one? No matter where you happen to be, you should always know the location of the nearest extinguisher. Go take a look at it. Has it been inspected? Fire extinguishers should be inspected regularly and at least once a month. Even if your company inspects them, you should look them over to make sure they meet 3 requirements. 1. Is the extinguisher charged? The pressure should always be at the recommended level. On extinguishers equipped with a gauge, the needle should be in the green zone, not too high and not too low. 2. Are all extinguishers mounted correctly? The top of an extinguisher should never be mounted higher than 60 inches above the floor surface, and the bottom of an extinguisher should never be closer than 4 inches above the floor. They should never be used as door props or paperweights. They are not coat hangers or tool hooks. 3. Are they unobstructed and easily accessed? Never place anything in front of a fire extinguisher. In the event of an emergency, we can't waste time trying to find the extinguisher that's hidden by a box or impossible to reach because it's behind a piece of equipment. Most fire standards recommend that a clear and unobstructed path to the extinguisher be maintained at all times, with the access being at least 2 to 3 feet wide. They cannot be hidden behind doors, cabinets, or anything else. There are 2 important things to remember if you ever need to use an extinguisher. First, make sure that you never place yourself in a position where the fire is between you and a safe exit. Keep the fire in front of you and the safe exit at your back. And second, remember the pass system. Pull, aim, squeeze, and sweep. When you need to use the extinguisher, first pull the safety pin from the handle. Then, aim the extinguisher nozzle at the base of the fire. This is the spot where the flames are touching the fuel source. Next, squeeze the handle to activate the extinguisher. And finally, sweep the spray back and forth across the target. Continue until the fire is out. If you are unsure that you can put the fire out, evacuate the area. Thanks for watching and have a safe day. Moving machine parts have caused severe workplace injuries like crushed fingers or hands, amputations, burns, blindness, and fatalities. Machine guards are engineered to protect workers from becoming injured. For example, the guard pictured here covers a moving power assembly. When it is removed, you can see a flywheel that is used to pull enormous weight with its energy coming from a powerful motor. When this machine is operating, it poses a dangerous hazard without a guard in place. If a piece of your clothing got caught up in the moving wheel, it would pull your entire body in and cause severe, and in many cases, fatal injuries. Guards protect workers from the hazards associated with flywheels, fan blades, screw conveyors, and power transmission equipment. Guards also protect other points of access to machine tools, such as the side and rear openings in machinery. Workers should not be able to reach around, under, through, or over fixed guards. Machine guards also reduce the hazards from sparks or broken machinery. Fires resulting from inadequate machine guarding have destroyed businesses. Severe injuries can occur when guards aren't in place to stop machine parts that fail and are thrown out at high speed. Accidental contact is a major risk during the operation of a machine, but some workers will tell you that machine guards can slow an operation down, so they are encouraged to remove or bypass them. Unfortunately, removing a machine guard takes a hazardous condition and makes it much worse. Unauthorized removal, circumvention, or adjustment of fixed guards creates unnecessary risk. Accident investigations often show that guards are removed and not replaced following maintenance, installation, and repair. Guards are bypassed when work requires occasional access to hazard zones, such as during machine setup, clearing of jams, lubrication, and so on. But the machine should be completely shut down and protected from resuming operation until the guards are replaced. Working around any moving machinery has potential hazards. Know the hazards and control them before and during operation.
Energy. It's essential in the workplace. Because energy is always around us, we may take it for granted and underestimate the potential hazards. Accidental release of stored energy can happen in a second. but the injuries can last forever. The good news is, when proper safety procedures are followed, these accidents are preventable. That's the purpose of a safety lockout-tagout program. Let's take a deeper look at lockout-tagout, why we need it, who's affected by it, and the steps to safely apply and remove lockout devices to isolate hazardous energy prior to and after equipment servicing and maintenance. A wide variety of machines and equipment is used daily in industrial environments, but never forget the potential danger. Machines require energy to operate. Energy that's potentially hazardous to workers if not properly controlled during maintenance procedures. The consequences can last a lifetime. Hazardous energy comes in many different forms, such as electrical, mechanical, hydraulic, pneumatic, chemical, thermal, or other energy. All these energy types can unexpectedly start up equipment if not controlled. That's why the energy sources need to be identified and locked, blocked, or released before anyone services the equipment. Each year, nearly 10% of all serious workplace accidents result from the failure to properly control hazardous energy. In fact, failure to correctly perform lockout-tagout ranks in the top 10 citations every year. To help keep employees safe, lockout procedures are a combination of processes and products to isolate energy sources to machinery. Lockout procedures keep equipment energy sources from activating when you don't want them to, especially during maintenance, where employees are vulnerable to injury or death. In addition, effective lockout-tagout procedures minimize downtime and protect expensive equipment. Procedures ensure that machines are correctly shut down and restarted, avoiding equipment damage from incorrect shutdown or unexpected startup. The federal law that governs lockout-tagout is an OSHA standard for the control of hazardous energy. The law spells out requirements to disable equipment and prevent release of stored hazardous energy during maintenance. The primary focus is on general industry, but the OSHA standard also applies to other work environments. OSHA has specific standards for marine terminals, longshoring, and the construction industry. In addition, other industry-specific safety organizations exist, such as MSHA, the Mine Safety and Health Administration. The OSHA standard applies to businesses in any of these situations. When an employee is required to remove or bypass a guard or other safety device. When an employee is required to place any part of their body in contact with the point of operation of the machine. Or when an employee is required to place any part of their body into a danger zone associated with a machine operating cycle. OSHA has established the following general guidelines for lockout-tagout devices. Lotto devices must be manufactured from durable materials to withstand the industrial environment of their use. They must be substantial enough to prevent removal without the use of excessive force. They must clearly identify the employee who installed the device. They must be standardized within the facility by color, shape, and/or size. They must be singularly identified. Only lockout-tagout devices are to be used to control energy. And lockout-tagout devices cannot be used for any purpose other than controlling energy. Never use them to lock a toolbox, locker, storage area, ladder, or other items. Lockout impacts a variety of workers at a facility. The three categories are authorized employees. These are the workers specifically trained to lock out or tag out equipment in order to service or maintain the unit. Affected employees are the ones who work with or near the equipment being serviced. They are trained to recognize the lockout but not perform it. And other employees are those who work in or near an area where lockout-tagout may be used. They also need to be instructed to recognize lockout but not perform the lockout procedure. There are 4 key components to an effective energy control program. Beyond having sufficient safety padlocks and lockout devices on hand, there needs to be machine-specific lockout procedures, inspections, audits, and employee training. Machine-specific lockout procedures outline the specific steps and requirements that an authorized employee needs to complete to safely lock out a piece of equipment. This includes posting the procedure at the equipment location for easy reference. OSHA requires annual inspections and audits. Inspections ensure that employees are correctly following the energy control procedures. Audits verify that the written procedures correctly describe the steps to isolate the equipment's energy sources. And the 4th element of the program, employers are required to train their employees to make sure they understand and can follow lockout procedures. Retraining is required to maintain proficiency. Whenever an employee has a new job assignment, whenever control methods change, such as new steps due to equipment modification, revised steps for a procedure change. Every piece of equipment must have its own particular procedure for lockout. It may mean locking out a circuit breaker, locking a valve in the off position, or using a disconnect switch, to name a few. In general, there are 7 steps for safe lockout tagout. First, prepare for shutdown. Locate all the energy sources that power the equipment. Each source is identified on the machine's lockout procedure. Next, notify all affected employees that you're ready to start a lockout procedure. Step 3. Stop the equipment by following its normal shutdown procedure. Step 4. Isolate the equipment by turning off the energy at the main power source. Step 5. Apply a lock and appropriate lockout device to each energy isolating device. Each lockout point that is detailed in the lockout procedure. For example, a gate valve needs a gate valve cover. The lock or tag that goes with it must clearly indicate who applied the lockout device. If several people are going to work on a piece of equipment, each one must apply his or her own lock to the isolation device. This ensures that the energy source will remain off until each employee removes his or her lock. Step 6. Release or secure any stored energy. This may involve draining valves, releasing hydraulic pressure, blocking moving parts, or however it's detailed in your company's procedures. Step 7. Verify the power is shut off by trying to restart the machine. Once verified, return the machine's switch to the off position. After the service work is finished, there are 5 steps to release the equipment from lockout tagout. First, make sure all tools have been removed and all machine guards are back in place. Check that all employees are clear of the machine. If you can't see inside a piece of equipment, take a head count. Remove the lockout tagout devices. Each person must remove his or her own lock and tag. Before you restart the equipment, notify all affected employees that the lockout tagout devices have been removed. And finally, restore energy to the equipment in the order indicated by the lockout procedure. A high percentage of accidents happen just after shift changes. It's often due to a lack of communication. That's why you should meet at the lockout tagout device with the person you're relieving. And then, before you leave, meet with the person who's relieving you. In general, if a piece of equipment is locked out at a shift change, the person on the next shift has to apply his lock before you can remove yours. If for some reason the person who applied the lock is not available, the supervisor may remove the lock and tag by following the company's pre-established written procedure. The supervisor must verify that the employee who applied the lock is not at the job site and make reasonable efforts to reach the employee. Before that employee returns to work, the employer must let him know the lock or tag has been removed and the equipment is no longer de-energized. Working around hazardous energy can be safe, but only when everyone takes responsibility for their part in the safety lockout-tagout program. It starts with the employer, who establishes the safety lockout procedures and conducts training, audits, and inspections. And safety also depends on employees to learn and follow the procedures for lockout-tagout each and every time.
In 1983, the Occupational Safety and Health Administration, or OSHA, published their Hazard Communication Standard. This important standard was often referred to as the Employee Right to Know Standard because it was developed to ensure that workers had access to information and training about the hazards of the chemicals and products they were exposed to at work. One of the major requirements of OSHA's HazCom standard was for manufacturers and distributors of hazardous products to develop and make available material safety data sheets for their products. But while the OSHA standard mandated very specific health and safety information about the products be provided on the material safety data sheets, HazCom was a performance-based standard, meaning there was no specific format that had to be utilized by the manufacturers and distributors when developing their MSDS, nor were there any standardized hazard ratings or precautions. As a result, MSDSs took on all shapes and forms, in part because manufacturers and distributors used different formats as they prepared these documents. As you can imagine, that led to a lot of frustration among workers. Eventually, it was determined that the OSHA HazCom standard, as written, was not meeting its original intent, which was to help employees know exactly what they were working with, how it could harm them, and most importantly, how to protect themselves. So, in 2012, OSHA revised their hazard communication standard and did away with the requirements for material safety data sheets. Now, manufacturers and distributors of hazardous chemicals and products will have to start providing a new informational document called a Safety Data Sheet, or SDS. While the information contained on new safety data sheets is very similar to that appearing on the old MSDSs, the information will now have to follow a specific format and order. There is also a standardized hazard classification system that must be utilized on all SDSs to convey information about the physical and health-related hazards associated with that product. And the revised HazCom standard now requires that employers train their employees on how to read and understand the new GHS Safety Data Sheet format. So the standard changed from Employee Right to Know to Employee Right to Understand. As part of the revision to their HazCom standard, OSHA adopted the GHS formatting requirements for safety data sheets. GHS stands for the Globally Harmonized System of Classification and Labeling of Chemicals. The GHS is a standardized system, meaning there will be consistency in the information appearing in safety data sheets. This system was developed by the United Nations, which means that Once fully adopted and implemented, safety data sheets for products from around the world will be prepared in a standardized format, which is important in our global economy. In the new format, all safety data sheets will be broken down into 16 separate sections. The sections will always have the same titles and will always appear in the same order. Now let's take a look at the information that must appear on GHS compliant safety data sheets, starting with Section 1. Section 1 on safety data sheets is titled Identification. This is where you will find the name of the product as it appears on the container label, and in some cases applicable synonyms or chemical classification codes used for the product. You will also find supplier information, including the name of the manufacturer or distributor of the product, their address, and emergency contact number. And on some safety data sheets you may see supplemental information about the product, such as the intended use for the product, directions for its use, and possibly an expiration date. All this information must match that appearing on the container label. The second section of a safety data sheet is titled Hazard Identification. Here you will find the GHS hazard classifications for the product, including those for each health hazard and physical hazard, and their individual ratings in applicable hazard categories. You will also find the appropriate signal word associated with the product. There are only 2 signal words that are used in the GHS system, either the word danger, which indicates a relatively severe or immediate hazard, or warning, which indicates a less severe but still potentially harmful level of hazard. This section will also display one or several hazard statements. Statements such as these 2 examples give employees a quick warning about what hazards are associated with the product and differ according to the classification and categories of hazards presented by the product. Section 2 of the safety data sheet also displays applicable precautionary statements. These are also standardized in the GHS system and in general convey information about how to prevent or lessen exposure to the hazards of a product. And something fairly new to us here in the United States are pictograms. Pictograms are standardized icons that let workers quickly identify the types of hazards associated with the product. There are 8 different pictograms for the health and safety hazards covered in the GHS system. A more detailed explanation of hazard statements, precautionary statements, and pictograms is provided on our online tutorial titled GHS Labeling Requirements, which is also available for free on our website. And last but not least, information about any unclassified hazards that are not covered in the GHS system, such as combustible dust, will be provided in this section. Section 3 of Safety Data Sheets, titled Composition and Information on Ingredients, identifies chemicals contained in the product. This could be a single ingredient for a pure substance, or 2 or more ingredients if the product is a mixture or contains impurities or stabilizers that contribute to the hazards of a product. You will also find the common name and any synonyms that may be used for the product, as well as the applicable Chemical Abstracts Services, or CAS number. When the product is a mixture of hazardous chemicals, the safety data sheet will also list the concentration of all ingredients which are classified as hazards, expressed in either percentages or ranges by weight. And for chemicals where a trade secret is claimed, there will be a statement that the specific chemical identity and or its composition have been withheld as a trade secret. Section 4 on a safety data sheet describes the initial first aid measures that should be administered by responders to anyone who has experienced a chemical exposure. This information includes a list of aid for different routes of exposure, such as contact with eyes or skin, inhalation, or ingestion. Also included will be a description of the most common symptoms of overexposure, including those which are acute or delayed, and recommendations for immediate medical care and special treatment that may be needed in some severe cases. Section 5 provides the manufacturer's recommendations for fighting a fire that involves their product. Here you will find a recommendation for the most suitable type of equipment for extinguishing a fire involving the product, as well as information about extinguishers that are not appropriate for use. You will also find details about specific hazards that may develop when the product is involved in a fire, as well as hazardous byproducts that may be generated during the combustion of the chemical. And in some cases, you may see recommendations for special protective equipment or precautions to be utilized by fire brigades or firefighters. Section 6 of the safety data sheet provides the manufacturer's recommendations for responding to spills, leaks, or accidental releases of their product. This could include response measures for containment and cleanup methods to be used to prevent or minimize exposure for response personnel. This may include specific recommendations for protecting personnel involved in the response from specific hazards, such as sources of ignition or lack of ventilation, recommended personal protective equipment to prevent personnel from being contaminated during the response, and emergency procedures, including instructions for evacuation of response personnel when needed, as well as others located nearby. Section 7 will provide information pertinent to safe handling and conditions for safe storage of the product. The required information consists of precautions for safe handling to prevent or minimize the release of the chemical into the environment, to prevent exposure or contamination for personnel handling the product, and recommended hygiene practices, for example, prohibitions against smoking, eating, or drinking in or near areas where the product is being handled. And when the product is being stored, there may be a need to avoid certain incompatible materials or agents such as high heat or water that might cause the product to react. Section 8 of the safety data sheet, titled Exposure Controls and Personal Protection, lists the OSHA permissible exposure limits, or PELs, for the chemical or chemicals contained in the product. These mandatory limits dictate when it will be necessary to utilize controls such as ventilation systems or respiratory protection devices to protect workers from the ill effects of overexposure to the chemical. There may also be listings for voluntary threshold limit values, or TLVs, established by the American Conference of Governmental Industrial Hygienists, or similar limits recommended by other groups. This section will also list appropriate engineering controls, where applicable, such as recommendations for exhaust ventilation systems or enclosures to contain emissions. And, of utmost importance, you will find the manufacturer's recommendations for personal protective equipment, or PPE, including any special requirements for providing certain types of PPE, such as respirators, goggles, or gloves. Section 9 of the safety data sheet identifies all applicable physical and chemical properties associated with the product. While most workers may not care about this type of information, safety managers and engineers may have a need to know about specific information on the product, including but not limited to: what does it smell like? What does it look like? At what temperature does the product freeze or boil? They may also need to know at what temperature the product emits enough vapors to catch on fire or cause an explosion. How much vapor must be present at the point of ignition to burn or cause an explosion, and are the vapors heavier than air or lighter? And when dealing with corrosive products, it may be necessary to know the pH of the chemical. Section 10 of a safety data sheet is titled Stability and Reactivity. Here you will find important information identifying any other materials which may be incompatible with the product, as well as any conditions to avoid during storage or handling, such as temperature extremes, shock, and static discharge. There will also be information about any conditions that could cause the chemical to react or polymerize, as this could cause the product to release excessive pressure or heat, or create decomposition products that could be harmful to exposed workers. And when applicable, this section will also provide information about stabilizers that may be needed to maintain stability of the product. Section 11, titled Toxicological Information, lists the known routes of exposure the chemical can use to get into your system, including inhalation, ingestion, and skin and eye contact. Also listed are the effects of exposure to the product, which include acute and chronic effects, applicable target organ effects, and a description of symptoms associated with overexposure to the product. There will also be specific measures of toxicity where applicable, such as LD50. That is the estimated amount of a substance expected to kill half of exposed test animals in a single dose. And if a chemical is listed as an actual or potential carcinogen, that information will be provided in this section too. Section 12, Ecological Information. Section 13, Disposal Considerations. Section 14, Transportation Information, and Section 15, Regulatory Information, all deal with requirements regulated by other entities such as the Environmental Protection Agency or the Department of Transportation. Therefore, these sections are not regulated by OSHA, but appear in the safety data sheet to be consistent with the GHS format. And finally, Section 16 of Safety Data Sheets, titled Other Information, lists details such as the date the safety data sheet was prepared, if this is the original version issued or a revised version, and in some cases an overview of any changes that were made during the last revision. And in some cases, the manufacturer or distributor may choose to put other information about their product in this section, as well as any applicable disclaimers. Employers are responsible for gathering new safety data sheets for all hazardous chemicals and products to which their employees are exposed, and make sure they are readily accessible during each work shift to employees while they are in their work areas. And employers must provide training to their workers regarding the new safety data sheet format. All these things must be done by the deadlines established by OSHA in their revised hazard communication standard. Speaking of deadlines, here is an overview of some very important dates. The revised hazard communication standard, which requires the use of GHS compliant safety data sheets, was published on March 24, 2012. Manufacturers and distributors of hazardous chemicals and products have until June 1st of 2015 to begin distribution of the new safety data sheets. However, many of them have already started providing safety data sheets that meet the new format or will do so long before the due date. Therefore, OSHA requires employers to get a head start and begin training all their workers on how to read and understand the new safety data sheets, and they have until December 1st of 2013 to get that training complete. And on a related note, employers must also update their written hazard communication programs to reflect the changes brought about by the adoption of the GHS system of labeling and hazard classification. So in review, the revised OSHA Hazard Communication Standard, which has the goal of making sure employees understand what hazardous chemicals and products are in the workplace and how to work safely with and around those items, requires GHS compliant safety data sheets be developed and provided for all hazardous chemicals and products. These safety data sheets are standardized in format, will always be comprised of 16 sections that appear in the same order, and provides standardized warnings and precautions applicable to the product. Also, employers must provide training for affected workers so they can find and understand the information that appears on safety data sheets. If you have any questions about the GHS format for safety data sheets or about the hazards of any of the products you work with, contact your employer safety representative or feel free to contact the safety professionals at OSHA Training Services through our website. In 1983, the Occupational Safety and Health Administration, or OSHA, published the Hazard Communication Standard. This was one of the first major new standards since the original OSHA rules were published in 1971 and was often referred to as the Employee Right to Know Standard. That's because it was developed to help ensure workers had access to information and training about the hazards of the chemicals and products they were exposed to at work. One of the major requirements of the HazCom standard was container labeling. But while the standard mandated that manufacturers provide specific information about their products on container labels, HazCom was a performance-based standard, meaning there was no specific format that had to be followed. As a result, container labels took on all shapes and forms, in part because manufacturers were free to use many different hazard warning and rating systems on their container labels. As you can imagine, all these different labeling systems led to a lot of frustration among workers. The Hazard Communication Standard was not meeting its original intent, which was to help employees know exactly what they were working with, how it could harm them, and most importantly, how to protect themselves. So in 2012, OSHA revised their Hazard Communication Standard, and a major part of that revision was how containers had to be labeled. While manufacturers still have to put labels on their containers, now that information has to follow a specific format. And there is a standardized hazard classification system that must be utilized on container labels to convey information about the physical and health-related hazards associated with that product. The HazCom standard also requires employers to train their employees on how to read and understand the new GHS labeling system. So the standard changed from Employee Right to Know to Employee Right to Understand. To improve information available to workers, OSHA adopted the labeling requirements of the GHS. That stands for the Globally Harmonized System of Classification and Labeling of Chemicals. The GHS is a standardized system, meaning there will be consistency in the information appearing on container labels once this system is fully adopted. This system was developed by the United Nations, which means that, once fully implemented, container labels for products from around the world will be standardized, which is of increased importance in our global economy. Here is an explanation of the information that must appear on container labels. First is the product or chemical identifier. This may be the name of the product itself or, as in this label, the specific name of the chemical. This information will also match up to the safety data sheet, or SDS, for the product. Next is a signal word. There are only two that are used in this system, either the word danger, which indicates a relatively severe or immediate hazard, or warning, which indicates a less severe, but still potentially harmful, level of hazard. The next section contains one or several hazard statements. These standardized hazard statements give employees a quick warning about the hazards that are associated with the product and differ according to the classification and category of hazard or hazards presented by that product. The next section of the container label shows what are known as precautionary statements. These too are standardized in the GHS labeling system and in general convey information about how to prevent or lessen exposure to the chemical, as well as considerations for storage of the product, first aid procedures to be used when accidental overexposure occurs, and, where applicable, information on how to respond to an accidental spill or release of the product, as well as information about its proper disposal. Additional safety and health related information can be found on the product's safety data sheet. GHS compliant labels must also display supplier information. This is where you will find the name of the manufacturer or distributor of that product, as well as their street address and telephone number. On some labels, you may see supplemental information about the product, such as directions for its use and possibly an expiration date for the product. And a key new requirement of the GHS labeling system, and something fairly new to us here in the United States, are pictograms. Pictograms are standardized icons that alert workers to the various hazards of the product in a container. There are 9 different pictograms used in the GHS labeling system. Pictograms will appear on all container labels, each one depicting a different health or safety hazard applicable to the particular product in that container. Some labels may have only one pictogram because there is only one class of hazard associated with that product. However, most labels will probably display multiple pictograms. By the way, pictograms appearing on a product label can also be found on the safety data sheet for that product, where you can get even more detailed information about hazards and recommended precautions. The first pictogram we will discuss is an icon of a flame. Obviously, this is associated with flammable liquids, solids, and aerosols, and will appear on labels for those products. This pictogram will also appear on labels of products that emit flammable gases, those which are pyrophoric, which means the chemical can possibly ignite within minutes of being exposed to air, self-heating chemicals, self-reactive chemicals, and organic peroxides, which are found in many products such as catalyst and curing agents. This pictogram of a flame over a circle identifies materials that are classified as oxidizers. While similar in appearance to the flame pictogram we just covered, oxidizers are actually materials that cause or contribute more oxygen to the combustion process, making other materials burn much more rapidly than they normally would. So care must be taken to avoid storing these products near flammable and combustible materials. The third pictogram depicts an exploding bomb and appears on products that are explosive. It can also be found on labels for self-reactive products and for organic peroxides. The compressed gas cylinder will appear on labels of cylinders of compressed gas under pressure. Care must be taken when handling these cylinders because in the right conditions, a broken regulator or valve can cause the cylinder to become a projectile. Also, when a compressed gas leaks into an enclosed space, such as through a leaking hose or crack valve, the gas can fill up the space and cause an oxygen-deficient atmosphere. And some gases are liquefied so they can be placed inside a cylinder. Some of these gases rapidly expand and cool when released from the cylinder and can even cause frostbite injuries if the gas makes contact with any part of your body. The corrosion pictogram will appear on labels affixed to containers of corrosive chemicals and products. Obviously, getting something corrosive onto your skin could cause a chemical burn, and the same could be said if you get any into your eye. But these products can also be corrosive to metals, which means they could corrode containers and other articles made from metal, causing them to break or leak. The skull and crossbone pictogram identify chemicals and products that present an acute toxicity hazard. The toxic effects of overexposure to these poisonous products could even be fatal in the right doses. Acute means the effects happen relatively quick as opposed to over a long period of time, which leads us to our next pictogram. The health hazard pictogram identifies toxic chemicals and products that can cause health problems over a long period of time, such as carcinogens, which can lead to cancer, mutagens, which can cause alterations in your DNA and affect your offspring, reproductive hazards, which could affect the ability of men and women to have healthy children, respiratory sensitizers, which could cause you to have an allergic reaction when exposed to that chemical at even low levels after you have had an initial overexposure. Chemicals that can cause damage to or affect the function of certain organs, and aspiration toxicity hazards, which could lead to the development of chemical pneumonia. A very broad category of chemicals and products are identified by the next pictogram, which is an exclamation mark. This symbol is associated with several products and chemicals that, relatively speaking, represent lesser levels of health hazard, but still require you to take precautions. For example, many chemicals and products are considered an irritant to your skin or to your eyes, while others can have a similar effect on your respiratory tract when they are inhaled. This icon also covers chemicals that could cause you to have an allergic skin reaction after subsequent exposures, and some of these chemicals could have an acute effect on your health that, while less severe than those identified by the skull and crossbones pictogram, still require you to utilize precautions so you don't suffer any ill effects. Chemicals that have a narcotic effect on your central nervous system are also categorized in the exclamation mark group, as are any products that have a harmful effect on the ozone layer, although OSHA does not enforce the use of this pictogram for ozone damage because it does not directly affect the health of workers. And finally, this last pictogram appears on labels of chemicals and products that are considered toxic to plants and aquatic animals. However, while this pictogram may be required by other agencies to appear on container labels, OSHA does not enforce the use of this pictogram since it will not directly affect the health and safety of exposed workers. As previously mentioned, at least one, but in many cases 2, 3, or even more of these pictograms will appear on the labels of containers of chemicals and products covered by the OSHA Hazard Communication Standard, as well as on safety data sheets. So read them and heed them, as you will need to be aware of the hazards posed by the various products you use at work. Also, keep in mind that pictograms are not intended to replace all other hazard identification symbols, as some of those are required by other government agencies, such as the Department of Transportation or Environmental Protection Agency, so you may continue to see them on containers along with pictograms. And in addition to containers of chemicals and products that we purchase from vendors, employers will need to make sure that all in-house labeling systems incorporate the required information by the deadlines established by OSHA. Speaking of deadlines, here is an overview of some very important dates. The revised Hazard Communication Standard, which requires the use of GHS-compliant labels on containers, was published on March 24th of 2012. And OSHA is giving manufacturers and distributors of hazardous chemicals and products until June 1st of 2015 to make sure all containers display the updated labels. However, many manufacturers and distributors are already starting to use compliant labels on their containers, or will be doing so long before the due date. So OSHA requires employers to get a head start and begin training all of their workers on how to read and understand those labels, and they have until December 1st of 2013 to get that training done. On a related note, employers must also update their written hazard communication programs by June 1st of 2016 to reflect the changes brought about by the adoption of the GHS system of labeling and hazard classification. So in review, the revised OSHA Hazard Communication Standard requires GHS compliant labels to appear on all containers of hazardous chemicals and products. Those labels are standardized in the information that must appear, including the display of all applicable pictograms, which are visual icons that identify the various classifications of hazards associated with the products. And employers must provide training to all affected workers so they understand the information that appears on those labels. If you have any questions about the GHS labeling system or about the hazards of the products you work with, contact your employer safety representative or feel free to contact the safety professionals at OSHA Training Services.